Let us solve the remaining problem. So the problem number 7 is the direction of steepest descent for the function fx comma y comma z cos x sin y cos z at the point x comma y comma z, which is pi by 4 comma pi by 6 comma 5 by 4 is. So we have to find out the direction of steepest descent. So the direction of steepest descent is given by del f at some point, let's suppose p naught. So we will find out the gradient of f, then we will substitute the value of this point and take negative of that. Okay, so the gradient of the function x comma y comma z is given by del f, where fx is a partial derivative with respect to x, and fy is partial derivative with respect to y, and fz is partial derivative with respect to z. So the fx is sin y cos z minus sin x, and if we take partial derivative with respect to y, then cos x cos y cos z, and then with respect to z cos y sin y minus sin z. Then we will substitute the value of coordinates of the point pi by 4 comma pi by 6 comma pi by 4, and got this minus 1 by 4 comma root 3 by 4 minus 1 by 4. So the direction of steepest descent is given by minus negative sign of del of gradient of f at that point. So the direction of steepest descent is given by this. So the final answer is 1 by 4 comma minus root 3 by 4 comma 1 by 4. So this is our answer. So the second option is correct. Okay, if we have asked to find out the direction of steepest ascent, then directly we will take del f at p naught. In case of ascent, and in case of descent we will take minus sign of. If here is some property given, in the case of steepest ascent, if u is positive and maximum, then the direction will be u is equal to del f by modulus of del f. And if there is property that there is steepest descent, they will take, then fu is negative, directional derivative at point u is negative and minimum, and direction will be minus del f upon modulus of del f. And if there is no change, then directional derivative at point u will be 0, and this implies that u is orthogonal to del f. Okay, so remember these properties and try to solve the problem. And make sure you don't do any mistake in exam, because there is possibility that this type of question can be asked. Okay, so let us solve the 8th problem. Problem number 8. Which of the following is the equation of line that passes through the point this and tangent to the function at the point this? So the equation of line that passes the point p naught and tangent to the function fx comma y at the point at point p comma q is given by this. This is a parametric form of equation, and we will substitute this point p naught passes the point v naught and tangent to the function at this point. So we will find out the gradient of f and substitute the value of this point. And so we will extend this formula for 4 variables. So in question there is given point 1 comma 2 comma 3 comma 4, the function. So the equation of line is passes through this point 1 comma 2 comma 3 comma 4, and first we will find out the gradient of f with respect to p, with respect to q, and with respect to r, and with respect to x. We will find the partial derivative, which is this, and substitute the value of 1 comma 3 comma 5 comma 1 and get 3 comma 5 comma 11 comma 7. So we will directly substitute this into this formula 1 comma 2 comma 3 comma 4 and alpha times of 3 comma 5 comma 11 comma 7, and the answer is this. Okay, so first option is correct. So proceeding with the next problem. So the question number 9 is the characteristic polynomial of a matrix with eigenvalues 1, comma 2, comma 3, 3 and 4 is. So the for characteristic polynomial we have to solve a minus lambda I is equal to 0, where I is an anti-matrix and a is any square matrix. Okay, a is any n cross n matrix. So in this case, in general we will get the value of lambda, and since there are 4 eigenvalues, we have written a b c and d. Assume we have 4 eigenvalues, and this is a function of lambda. Since this is a function of lambda, and this is called said to be characteristic polynomial, and this whole equation is said to be characteristic equation. So we have to find the characteristic polynomial. So we will directly substitute the value of a b c d, which is given as 1, comma 2, comma 3 and 4, and simplify this equation and got the characteristic polynomial. Lambda power 4 minus 10 lambda cube plus 35 lambda square minus 50 lambda plus 24. So the matching answer is option A. Okay, so let us proceed with the problem number 10. In problem number 10, if null space of a matrix A is given by this span of this vector, then which of the following can be row space of matrix A? So there are options given. So we have given null space of A. Null space of matrix A is span of this vector. So as we know that row space is orthogonal to null space of A. So this implies that dot product of row space of A and null space of A will be 0. So we will check all the 4 options where we are getting this dot product of row space of A and null space of A is 0. So the first option we have checked, and assume this is a vector v1 and this is a vector v2 which span the whole row space. Okay, so we will check v1 transpose multiplied by null space of A, which is given in the question, and we calculated the dot product, which is 0, and for v2 vector is also it is 0. So since the dot product of a row space of A and null space of A is 0, so this is our correct option, which can be, so this can be a row space of matrix A. So the first option is correct, and you can similarly check for other options. I have checked for option B for your understanding, where v1 transpose we have calculated minus 107 by 17 with this 7 by 17, 22 by 17 minus 1, and since this is not equal to 0, so this option is incorrect. Similarly, we will check for the rest of the option, and unfortunately we are getting not equal to 0 for the rest option as well. So the only option is correct. So okay, so proceeding with the next problem, question number 11. So here is given a matrix A, and we have asked then which among the following is orthogonal to column space of A. Okay, so we have given a matrix, and we have to first convert it into a row echelon form. First we have to find the column space of A, then we will talk about the orthogonality. So the column space of A is linear combination of column vectors. So we have converted this matrix into a row echelon form, and these are the pivot elements. So these pivot elements belong to this vector, column vector, and this pivot elements belong to this column. So our column space will be combination of these two vectors, and so the column space of A is 1, 2, 3, 5 and comma 1, 0, 1, 1. So here is we have some point to remember. You have to remember these points. First is row space of A is orthogonal to null space of A, and row space of A is equivalent to column space of A transpose. So these two statements are equivalent to each other. And third is some more property. And third is, you have to remember, what is this? Column space of A is orthogonal to null space of A transpose. So we have calculated the column space of A, and we have to find the null space of A transpose, because in the question it is given which among the following orthogonal. So the orthogonality property holds with this property. So the column space of A is orthogonal to null space of A transpose. So we will calculate the null space of A transpose. Since null space of A transpose is orthogonal to column space of A, so we will find null space of A transpose, and A transpose is 1 2 3 5 1 0 1 1. We have taken the transpose of matrix A, and we have to find the null space. And null space if vector S is such that A transpose X will be 0. So we will solve this equation, matrix equation 1 2 3 1 0 1 1 x1 x2 x3 x4. So to solve this system of linear equations, we will first reduce the A transpose into row echelon form. So I have converted in by row operation. I have converted this row echelon form, and these two are pivots element. So the pivots element correspond to independent vectors, and these are not pivots elements. So these are x3, x4, and x1, x2. So x1, x2 belongs to pivots elements. So the vector x1, x2 are independent vectors, and x3, x4 are x1, x2 are independent variables, and x3, x4 are dependent variables. Free variables. x3, x4 are free variables, and these two are independent. So we have assumed x3 is equal to 1, x4 is equal to 0, and solve this A transpose x time is equal to 0, and A transpose, I have substituted this row echelon form of the matrix. So I have calculated the x1 and x2 with the help of this equation, and substituted the value of x3 as 1, x4 is equal to 0. I have substituted x3 as 1 and x4 is equal to 0 because in the all options you have seen that there is 1 0 1 0 1 0. For the free variables it is given 1 0. So the free variables, in the case of free variables, you can take any value. So I have taken 1 0 because in the all options it is given 1 0. So we have taken 1 0, and for the one x3 as 1, x4 is equal to, we have calculated the value of x1, x2. So I have calculated the value of x2 as -1, and x1 is equal to -1. So the vector v1 corresponds to -1 -1 1 0. Similarly, set x3 is equal to 1, x4 is equal to 2, because in the options it is given x3 is equal to 1, x4 is equal to 2. So I have calculated the value of x1 and x2 for this case, and I have got this vector v2. So the null is for V transpose is span of these two vectors v1 v2. So the span of -1 -1 1 0 and -3 -5 1 2. So our answer is this. A option is correct. Okay. So let us proceed with the next problem. In this problem, you have to remember this property because it is very important. You can expect this type of question in exam. Okay. What is this? Row space of A is orthogonal to null space of A, which is equivalent to column space of A transpose is orthogonal to null space of A. These two are equivalent. And third is another column space of A is orthogonal to null space of A transpose. Okay, you have to remember these two. So let us proceed with the next problem. So the problem number 12. So what is problem number? Problem number 12 is very easy. For the data set, these are 5 data sets, 1 to 5. Consider the regression model fx equal to x square plus 1. And what is the mean squared loss for x? So the mean squared loss for function is given by this formula, and I have tabulated these points. So the x1, and calculated the value of fxi with the help of this model. I have calculated the value of fxi, which is this. For the first it is 2, for second data set it is 5, for third data set it is 10, for fourth is 17, for fifth it is 26. I have taken this expression, but calculated the value of this expression, and which is 111,440, and simply you can calculate loss by summing all these values and divided by number of data sets. So the number of data sets is 5, and sum of all these points are 10. 10 divided by 5 is 2. The answer is 2. So let us proceed with the problem number 13. Problem 13 is, if projection of vector A of length 10 units onto vector B of length 8 units has a magnitude of 5 units, then the length of projection of vector B onto A is. So assume there is some vector B, and B of length 8 units. Okay, this you can say it is 8, and there is some vector A which is of length 10 unit, and we have to project this vector onto this B vector. So the projection of vector onto has magnitude 5 units. So this length is 5 units. You can extend this. This is 5 unit, and this whole is 8 units, and we have projected this vector A onto vector B. So I have drawn a perpendicular line from this vector. Okay, so this is a visual representation of this problem. If we project this vector onto this vector, then there is a set magnitude of projected vector is 5, and now it is asked the length of projection of vector B onto A. So now we want to project this vector, project B onto A. So to project this vector onto A, we will draw a perpendicular line from this vector onto vector A, and now we have to find this, what is the projection of this vector onto this vector A. So one projection is given, and second projection we have to calculate. So here is one formula for projection of vector V onto A. So the projection of vector V onto A is given by this formula. Similarly, projection of vector A onto B is given by this formula. Onto projection of vector V onto A, onto is in the denominator. Similarly, onto B, so it will be in the denominator. So for first case, it is given as projection of vector A onto B. Okay, so A onto B, so it is given A dot B. So we have this is value is given as 5, and this modulus magnitude of vector B is 8 units. So we will calculate dot product of these two vectors as 40. Okay, now the length of projection of vector V onto A. So now we have to ask B onto A. This is asked B onto A. So we will again calculate A dot B is we have calculated as 40, and magnitude of A is 10. So we will divide by 40 by 10, which is 4. So the answer, our final answer is 4. So let us proceed with question number 14, which is last question. So for a 3 cross 3 matrix A whose nullity is equal to 1, what is the value of rank of A plus dimension of column space of A plus dimension of column space of A transpose? So here RA stands for rank of A, dimension CA stands for dimension of column space of A, and dimension of column space A transpose. Okay, so we will there is some points you have to remember. Rank of A is equal to dimension of column space of A, and nullity is equal to dimension of null space of A, and row space of A is equal to column space of A transpose. Column space of A transpose is equal to span of rows of A. Important. So there is some formula: column of rank is equal to dimension of column space of A, and row rank is equal to dimension of row space of A. So this implies that column of rank is equal to row rank. So you have to remember these points. So from these points, we can easily calculate the answer of this question. So there is 3 cross 3 matrix given, and given nullity is 1. So the from rank nullity theorem, rank of A is equal to 2. So rank of A is equal to 2, and dimension of column space of A is equal to row rank, and this is also equal to row rank. So we will directly substitute the value 2 plus 2 plus 2 is equal to 6. So the final answer is 6. So thank you. That's all from my side. Hope you enjoyed this video and subscribe for more such videos. Thank you.